Hey, it's Mr. Allred, and we've been graphing rational functions, so we're going to go through this one and do the attributes and graph it. So the function is f of x equals the fraction x is the numerator and x squared minus 9 is the denominator. So as we go through this, the things we like to look at are the domain, which will give us our vertical asymptote. So the domain of this thing is restricted by the denominator x squared minus 9, and that can't be 0. So I can factor that to solve it. It's a difference of squares. It'll be at x plus 3 times an x minus 3 can't be 0. If you set each one of those equal to, not equal to 0, you get x is not negative 3 and x is not 3. So that domain leads you straight to your vertical asymptotes. So your vertical asymptote will be negative 3 and a positive 3. So the domain issues that we had here lead directly to the vertical asymptotes in this case. So I'm going to come over to my graph and I'm going to throw in the negative 3 for x, something our graph will get close to. And I will throw in the 3 as well. So we know we don't have values at negative 3 and 3. And we can't cross over there. So the next thing we want to do is look at the horizontal asymptote. And in that case, we look at the exponent on the numerator and the exponent on the denominator. The exponent on the numerator, you don't see it, so it must be 1 there, x to the first. And then on the bottom, x squared. So basically in that case, if we're going to talk about it, if you go back to your horizontal asymptote rules where m is your top exponent, in this case 1, n is your exponent on the bottom, in this case 2, m is less than n in this case. So remember, that led to the fact that we'd have a horizontal asymptote at 0. So my horizontal asymptote is y equals 0 because the bottom exponent is bigger than the top. Okay, so I'm going to put that in. And also, while I'm doing this, remember that if we have a horizontal asymptote, we can't have an oblique. Okay. So we need to pick some numbers to plug into this function, x over x squared minus 9, to kind of calculate and see where things go. And we're just going to do our best. The more points we pick, or the more strategic our points are, the better it will work out for us. I'm going to put them in order here, but I need something less than negative 3, so negative 4. I need something a little bit bigger than negative 3, so I'm going to pick negative 2. My other asymptote is at 3, so I need something on both sides of there. So I'm going to use 2, and I'm going to use 4. I'm going to calculate all these. So I'm going to pause the video, and you can do it as well while I calculate them. Okay, so to pick up where we were, I've calculated the points, and let's see what we've got. So when I had I plugged in negative 4, I got negative 4/7. So that's a little bit below the x-axis. Now, in trying to make sense out of that, we know we got to get close to both the horizontal and vertical asymptote over here. So the most logical thing would be that it just kind of curves around the bottom side here. Okay, so dropping that into the bottom below the horizontal asymptote, but making sure it gets close to it, and also picking up that vertical asymptote at negative 3. Now, generally, if you have a middle part of a graph, that would be the hardest part to deal with. So I'm going to do both tails. So I've already done the left-hand side. So let's do the right-hand side where when I plugged in 4, I got 4/7. So I got this point up here above the x-axis. So generally what happens there is I'm just going to kind of draw my curve to kind of fit it. So I have to come down by the vertical asymptote at 3, and I have to travel along the horizontal asymptote as I move away from the center. So I've got my 2 tails. Okay, so this point here, the negative 4 and the 4 let me know where to put those. The two middle points here, -2 gives me 2/5. Can't be exact, but it's a little bit above the x-axis. And over here at 2, we got -2/5, which is a little bit below the x-axis. So I'm not going to guarantee that this is the way it's going to work every time, but a few things here. One, you can cross the horizontal asymptote. You can't cross the vertical, but you can cross the horizontal. The horizontal is only a characteristic as you move further and further away from the center, so as these tails go. But we need these middle parts to do the right thing with the vertical asymptotes, so it makes sense that this one is, as I move to the right, is going to go down forever, and as I move to the left, it's going to go up forever. Okay, and something that usually helps you here that may not always be correct because every function is a little bit different, but you can use it as a predictor. Usually if you have a vertical asymptote, you can almost, I don't want to say guarantee, but a lot of the time, unless you have a strange function, you'll notice that the size of the vertical asymptote go in different directions. So one's going down, one's going up. So that's why it's kind of helpful to get those tails. But I wouldn't take that as gospel. I would take a couple points like we did and just see if that makes sense for the problem. But here we are. We've completed this example. Very quick, really, in getting these vertical and horizontal asymptotes. Everything else is really just a judgment call on calculating. And if you want better graphs, you just have to calculate more points.